Okay, working our way through, we've got number 3 here. Find the fifth roots of unity and display them on an Argand diagram. So again, we're using this rule, or this formula. Hopefully we're up with that by now. So I hope you agree with this. And therefore we end up with z equals 1. W will be cis 2 pi on 5. Okay, W2 will be cis 4 pi on 5. All I'm doing is I'm timesing because you're squaring, right? Because W squared equals cis 2 pi on 5 squared using de Moivre's theorem, right? Becomes 4 pi. And of course, then we get 6 pi. Now, if you're being asked to just leave these in simplest polar form, remember, these last two will not be any good because our angle has to be between pi and minus pi. Okay, so you would have to rewrite that. Just take away 2 pi from each of them and we'll be right. Okay, we're going to display them on an Argand diagram now. So easier for me if we just go, so they've all got, oh, that's not a good circle. Not too bad. That's not great. Sorry, should have drawn that first and not kept you looking. Okay, so our 1 is going to go there. So that would be obviously 1. And then cis 2 pi on 5. The other 4, they're split evenly around. So you sort of break them up. What's 360 divided by 5, right? So roughly 72. So you want to just break that up. Break that up. Okay, got that one. And we've got that one. And technically, right, so this is cis 2 pi on 5. And then this one here, these are complex conjugates, right? So this angle here should be the same as that one there. Okay, and these should be, mine's not great. Maybe I should redraw that one. Okay, that should actually be a little bit on the even side. So a couple of things to look for. So this would be cis 4 pi on 5. And this would be cis minus 4 pi on 5. So make sure that you've got your conjugate pairs, but also make sure that they're evenly spaced, right? So that angle, so this angle, this one, and so on, they should all be pretty much even. But, you know, they're not asking you to draw it to scale, so don't worry too much about that. Okay, I think I probably did, this one was B, and if I wanted to do A, then we have to go through the whole z to the 5. 1 is cis 0 plus k2 pi, etc., etc. We just did that in the previous question 2, so you could probably have a look at that yourself. All right, let's move onward to C. Okay, simplify, blah, 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 and hence show that. Okay, so simplify. I guess we expand. So we're going to go 1 plus w squared plus w cubed just timesing everything through by the 1. Now we're timesing everything through by w, so 1 times w is w minus w squared minus w cubed minus w to the 4 minus w to the 5, and things are going to cancel, and we're going to be left with 1 minus w to the 5. However, we know that w to, oops, and we do know that, no whoops there, but the next one here, w5, it actually repeats, so it becomes the 1. So because w to the 5 equals 1, this becomes 1 take 1 equals 0. So we've simplified that to say that that whole thing there equals 0. Hence, show that w plus blah, 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 blah equals 0. So hence, show that this is 0. So going back to our factored thing over here, right? Why does this factor equal, this one here, equal 0? Well, if we go back and look at our roots here, there's our w, right? That cannot equal 1. We've already got 1 as our solution there, so w is not 1. You can see it clearly here. It would be the next root. So for this whole expression to equal 0, either 1 take w has to, so 1 take w has to equal 0, and because w cannot equal 1, well, that's not going to happen. Okay, which means for that whole expression to equal 0, then that would mean that 1 plus w plus, so we're going to say since w does not equal 1, then 1 plus that other factor has to equal 0 for, just write that whole thing again, 1 plus da 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 plus w to the 4 times 1 take w to equal 0. It's the only way that it can happen. And show by vector addition. So basically that's going to be, instead of a square now, we've got 1, 2, 3, 4, 5. You would have a pentagon that would go around, right? So I'm going to be naughty and do it over the top here. Let's go maybe see if white shows up nicely. You would have that one going there. Okay, this one, the blue, right, that goes out there. And then this one goes there, and then this one comes down like so, and then we've got the last one. So you actually get like a pentagon. Put your arrows in.